vividly when Swift was first introduced. I was attending WWDC in San Francisco, and I was floored. I mean, I was just shocked. And I heard them say, interoperability and incremental migration, we still love Objective-C. I heard all those things. But all I remember feeling the entire week was, this is a huge change. And it was a huge change. I'm not trying to minimize it. I mean, we're naming conferences after this thing, right? But after I had a chance to process my feelings and sit down and actually use this language, I discovered that what they were saying was true. I could pretty much just write the same code as before and just use a little bit of a different syntax. And it's been 10 years now, apparently, since Swift was introduced. But there are still projects out there with huge amounts of Objective-C in their code base. And it's weird, maybe, that I'm talking about Objective-C, because I'm sure there are people in the audience, these are professional Apple platform developers who have never written a line of Objective-C in their entire life, and they probably never will. And that's amazing to me because the interoperability really is good enough that they're probably also regularly making use of Objective-C APIs. And this is just kind of what these big, long-term technical transitions look like. They take a very long time. It's kind of not even obvious sometimes when they're done or if they even need to be done. But the reason I'm talking about and thinking about that transition so much is because we're kind of starting this new one with concurrency. And you know, when I first started, using Swift, I was writing Objective-C, but I was using Swift to do it. And then as I got more comfortable with this language and learned more about what it had to offer, I started incorporating more of the features into my own code. And then over time, that really had this big impact on the code that I wrote, on the designs that I was making. And I think that concurrency is a profound change to the language. And I think that it will have a really profound impact on our designs as well. When I first started putting these slides together, I thought I was going to show you a whole bunch of code, like just go through source code, and that's getting technical is always fun. But as I was doing that, I realized that really what I wanted to do instead was talk more about trying to understand what Swift concurrency is even trying to do here. And more specifically, I hope that I can help you avoid some of the misunderstandings that I had when I first started and that I see people have all the time today. I want to start with the highest level possible question. Like, what even is this thing? What is Swift concurrency? What is it trying to do? And to answer that question, I think we have to look at what Swift, the language, is trying to do. Now imagine all code that can be compiled successfully in Swift. This is a big set, right? But only a small subset of it can actually result in correct code. Most of this is going to be compile fine, but be totally invalid. And Swift has this huge emphasis on safety. And the whole idea here is to try to shrink down that circle a little bit, to take code that maybe was going to fail at runtime and instead turn it into a compile time failure. And of course, it has to add some constraints to the language. And that means some more work for the programmer, but the hope is a little bit more work will result in a lot more safety. And of course, this is something that you can't get for free, right? This is going to have a cost. Now, the problem that the language is tackling here, this is not a trivial problem, right? We're getting into the domain of programming humor here. And I like this one, but I actually think this one is even funnier. Now, the reason these jokes exist and why they're funny is because this is like this universal problem across all developers, all programming languages. Threads are just very difficult. One way to sidestep this problem is just to not use more than one thread. Put all your mutable state on one single thread, and as long as you do that everywhere and everybody agrees, then that can work out. It kind of sounds like maybe a silly solution, but this is what the main thread is doing. Of course, eventually, you're going to want to make more use of that computer hardware, and so you have to use more threads. And then you might need to reach for something like a lock. And locks are very powerful. And as long as you take them in all the right places and protect all the right stuff and then release them perfectly everywhere, they work well. There's another tool that's probably familiar to most people in the room, and that's a queue. And it's this wonderfully simple way of modeling work that happens maybe on one single thread, like the main queue. But they can also take the place, in some cases, of a lock, and in a way that is a little bit easier to use. So we have these mechanisms, right? These are all things that allow us to control synchronization through the execution of our code. Threads, locks, queues. And what Swift concurrency has done is look at all these things and model them using one single abstraction, and that's called isolation. And this actually has a representation in the Swift type system. Now, isolation is a concept, but the actual thing at runtime that implements the isolation, that's an actor, capital A, right, the actor protocol. And all the types that conform to the actor protocol, we can reference those with any. The weird thing about this type is for some reason it's optional. What does this even mean? Well, nil is how we describe something that doesn't need protection. And in fact, that also it shows up as a keyword. This is non-isolated. And this keyword trips up a lot of people. And I think the reason why is that it feels like this unsafe thing. It feels like you're turning off protections of the language. And while you cannot turn off protections of the language as a whole, this is kind of exactly what it's doing. But the reason why it works and has a purpose is because there are types that just are inherently thread safe. There are functions that don't touch mutable state. They can be non-isolated without sacrificing any safety. Now, I want to take this further by showing you an example. And this is a real question that someone asked me not all that long ago. They were trying to use the multi-peer connectivity framework, which is something I have never used before. And to be honest, I don't fully understand what it does, but that is not important for this problem. Here's the code they were trying to do. They were trying to implement this delegate protocol. And they were following a tutorial, and they were using Swift 6, and they were having a very hard time. And so I asked them, well, what queue does this delegate get called back on? And they thought for a second, and they said, you know, I don't know. I said, okay, well, what else can we do? So we looked for documentation, which existed, and it was very clear. It said all these delegate callbacks happen on background threads. And the reason this person was struggling so much is because the tutorial they were following was touching main thread only state in this function body. And like, that's cool, the compiler found a bug. But why I like this problem so much is it illustrates another thing that Swift concurrency is trying to do, which is it's taking information that you hope you can find in documentation, and it is moving it into the type system in a way that you can no longer ignore. Now, this person was struggling. I mean, they're using Swift 6 for the first time. They're encountering a bug in this tutorial they're following. And they were using an API that I think was a little bit tricky. But you might be thinking to yourself, like, is it always going to be hard like that? And I think that the answer is yeah, it is going to be hard. And the reason is that concurrency is just everywhere. It's in almost every API, every framework, and you only need to hit one situation that's difficult to make your life hard, and you're not going to hit just one. In fact, I had a hard time even coming up with a good list of reasons why it could be hard. One, for sure, though, is it's just really different from how we're used to doing these things. These traditional systems where you're controlling concurrency, threads, locks, queues, you're controlling your behavior through the execution of your program. That's possible, but it's just not a thing that we're doing as much anymore. And I have seen people, when they get started, they are replicating these patterns from GCD, but they're using Swift concurrency primitives to do it. This is fine and works correctly, but it stands out more when you start realizing how involved the type system is. And this gets particularly difficult because there are systems that exist that cannot be fully modeled using just the type system. And in fact, Swift concurrency has totally embraced this. They have this top-level system called dynamic isolation. And the whole idea with this is you express to the compiler these invisible constraints. And it will trust you, but it will check at runtime. And so if there are problems, this will result in runtime failures. And if you can model your concurrency using the type system, this will be transformed statically into compile time failures. And even doing this, even if you can describe your system this way, you can still potentially run into issues related to interoperability. As we're talking about Swift 6, but maybe you need to call into Swift 5. Well, is that the Swift 5 language mode, or is that Swift 5 compiler version? And or are the warnings on, or are they off? And what about Objective-C? Is that in the same module as the Swift code, or is that in something else? There's just a lot of possibilities. And these situations, there's tools to deal with all of them. But inevitably, you're going to hit a situation, potentially even in first-party code, where you're missing these annotations. And this is a problem because the compiler is using the type system to make decisions about how things should happen at runtime. And with missing annotations or incorrect annotations, it will also do the wrong thing at runtime. I want to give you an example of what that can look like. So here's some code. This is just a function that's taken a callback, and it is running some work on a background thread, and then it's executing that callback. This is totally valid Swift 5 code. But if you call this code from Swift 6, it can potentially be a big problem. And the reason why has to do with the type of the closure. You see, what's happening is where this is being called, let's say it's being called on the main thread, that closure is being formed there. And then it's being transported from where it's formed to the background thread where it's executed. And Swift concurrency is very clear about this. The only types that are allowed to do that kind of thing are sendable types. And because this closure is not marked sendable, the compiler will make the assumption that this cannot happen in a way that could seriously impact runtime behavior. Now, one really easy solution is to express this reality in your API. Just change it and add @sendable. But if you do something like this, you've actually introduced another interoperability problem, which is now you've opted this API into a concurrency feature in a way that will no longer suppress warnings, even for Swift 5 clients that don't have warnings turned on. Now, there's a way to deal with this as well. It's a little bit of a confusing system sometimes, but you can conditionalize your annotations based on whether the client wants warnings or not. And you can do that with the @preconcurrency annotation. And the reason why this annotation is a little bit confusing is because it has different meanings depending on whether you're using it to consume an API or make an API. But in this case, this is how you can do this to achieve correct interoperability for both Swift 6 and Swift 5. Now, there's one more situation I want to talk about, and I think this is probably the most difficult one. And this is, you're using Swift 5, you've adopted concurrency, but you have the warnings turned off. And I wouldn't blame anybody for doing this. I did this, and that's because it's the default. Right? Even with a brand new project in Xcode 16, you're going to get the Swift 5 language mode with no warnings. But what you're doing here is you're kind of like turning off a part of the type system. And by doing that, I really think what you have is this dialect of Swift. And I think this dialect is very unsafe. And it's unsafe for two reasons. The first is it makes it seem like you can make these straightforward transformations from callback handler to async function. And even the compiler will automate that for Objective-C code. But in reality, sometimes that can introduce some semantic differences that can result in you adding race conditions into your code, doing the exact opposite of what Swift concurrency is supposed to do. The other problem, which maybe is worse, is without this compiler feedback as you're working, you can start to build these APIs, these whole systems, that can just never really end up being error-free in Swift 6. This is exactly what happened to me, and it's certainly not a guarantee, but it's a real risk, and because of that, I just think you should do this. So there's a lot working against us. Yes, it can potentially be very hard to adopt Swift 6, and you might be thinking to yourself, should I even do it? And if you're struggling with this decision, I think it really has to be just crystal clear in your mind why you're doing it, and more specifically, why you're doing it right now. Because there are a lot of people who I've spoken to who feel like this is not really an optional transition, right? Swift 6 has shipped, and we need to get on this right now, because the last thing you want to do is writing brand new code that is obsolete from day one. And I very much sympathize with this feeling. But let me tell you what happened to me. So Swift concurrency was actually first introduced 3 years ago with Swift 5.5. I didn't start right away. I like to wait about a year. And then I started incorporating it more. And I think I finished migrating pretty much all my projects around Swift 5.10. And it was not easy. I had a lot of really complicated workarounds, and I had to learn a lot about how it actually worked in order to be able to just succeed at doing this. And then Swift 6 was released. And I know its whole purpose was concurrency, but this version introduced all kinds of new features, fixed all kinds of bugs, and made a lot of the work that I did obsolete. There's all kinds of workarounds that I have in there right now that are no longer necessary. In fact, some of the features that went into Swift 6 are based on research that didn't even exist when Swift 5.5 shipped. This transition, I want you to think about it as taking years. And so if you can, try to feel like zero pressure to start this now. And I know that's impossible because Swift 6 is out there. And maybe you're not the only person making that decision as part of a team. It can matter whether you're working on an app or a library. And that build setting is right there. Right? It's very tempting. You're just going to change it to 6 just to see what's going to happen. And of course, we know exactly what's going to happen. Right? You're going to see errors. You're going to see potentially an enormous number of errors. And for a lot of people, that is going to make you afraid. And what you're going to start doing is just frantically trying anything you can to make the errors go away. And sometimes that's actually exactly the right way to handle this problem, but you're missing this really important opportunity to understand what the compiler is trying to tell you, and maybe actually find some real bugs in your code. Maybe find some areas of your design that are fine, but that you want to revisit. I know that Swift 6 has been released, but I like to think of it more like concurrency 1.0. Right? And we know what happens with 1.0 is they're very usable. And I do think that Swift 6 is very usable, but it also has sharp edges. And that's something you have to be aware of if you're going to get into this. I spent a lot of time using a beta of Swift 6. And you know this expression, it's never the compiler? Well, I filed a lot of issues during that beta, and actually still after it's been released. I do want to say, though, that this was an amazing experience, right? For people that are used to using Feedback Assistant to file problems with Apple, the amount of visibility and transparency you get into what's going on here, you can see whether someone has looked at your bug, whether there's a possible workaround. They'll often, I have had compiler engineers explain what's going on, tell me when the problem is going to be fixed. It's really an unbelievable experience. So, of course, if you're having compiler problems, for sure, file bugs. But also, you should do it just for the experience, because it's awesome. Now, here is a question that I do not want to enter your mind, right? Because of course you can do it. But you have to be aware that if you decide to do it now, you're going to be taking on some real work. There's a lot of learning involved, a lot of potential frustration, and it's taking you away, potentially, from other features and bug fixes that you could be doing. So it has to be very intentional. But if you decide to do this, I want to give you some tips, some thoughts, maybe some opinions. One thing that I have noticed, and it's strange, but I can't deny this trend, is it seems like sometimes the people that have the most expertise in concurrency are the ones that are struggling the most with it. And I think, this is just speculation, but I think one of the reasons why is these are people that have so much practice, developed so much intuition in how to do synchronization by controlling execution, that even if they intellectually understand that it's a very different system and that the type system is now involved, they don't have the same experience. And it can be just hard to make that transition in a way that beginners seem to be having a much easier time with. Now, speaking of things that we're familiar with, we're all like trying to keep that app responsive, right? Keep work off the main thread. And in some cases, that has resulted in apps that just have way too much concurrency in them. And this can have a really negative impact on performance today, but when you move to Swift 6, the compiler is going to force you to deal with this situation in a way that can be extremely painful. And one of the ways I have seen this regularly manifest itself is you've got these reference types, and you just desperately need these things to be sendable, right? And that is potentially the right solution, but before you do something like reach for actor or unchecked, I want you to think harder about why this type needs to be crossing domains in the first place. Why is it moving from thread to thread? And if you could maybe just remove a tiny little bit of concurrency, sometimes you can avoid needing these types to be sendable altogether, and that can be a much easier solution, and can also sometimes better represent the true nature of your system. Now this goes hand in hand with, you gotta understand the errors. You can sometimes not do this, but I think it's really unavoidable if you want to be able to change your Swift 5 code into Swift 6 in a way that you can feel confident you've done some positive work. And you will eventually develop intuition on how to do this. And you'll get more comfortable, confident. Maybe you're going to start throwing some actors in there. And then you're going to have this system that's working great, except for this one little synchronous access that's just messing everything up. And I want you to pay really close attention when this happens, because sometimes you've got this system that you want, that you really like. And what the compiler is telling you is that system cannot solve the problem that you have. Synchronous accesses, they really define the true nature of the bounds of isolation in your application, and you cannot ignore them. So I want you to pay close attention when this kind of thing comes up. And one more tip I want to share is you should totally check out the forums. I mean, there are people on here that are very willing to solve all kinds of problems, including very beginner questions. Maybe also you're the kind of person who enjoys helping people out, and then this is a great place to do it. But also, regularly, the compiler team themselves are on here looking for feedback on potential changes they're going to make to the language. And I can tell you that it is not always easy to understand the evolution proposals. And it's not like you have to do it every time, but I think it would be wonderful if there were more people contributing feedback to this process. And so you should definitely sign up and take part. Now we circle back to this question, right? Can I do it? Of course you can do it, yeah. But if you're having trouble, if you're struggling or you have questions, it's possible I can help you. So I would love to. You can come and find me here. Thank you very much.